Hello everyone, in this video I will show how to use Analytic Solver to perform PCA, Principal Component Analysis, with 12 variables. Here on the screen you see country level health and population measures for 38 countries from World Bank's 200 Health, Nutrition and Population Statistics database. For each country, the measures include death rate per 1,000 people, which is in percentages, health expenditure per capita in US dollar, life expectancy at birth in years, male adult mortality rate per 1,000 male adults, female adult mortality rate per 1,000 female adults, annual population growth in percentages, female population in percentages, male population in percentages, total population, size of labor force, births per woman, and birth rate per 1,000 people. As I mentioned in the previous videos, PCA is especially effective when the variables are highly correlated. We can quickly check the correlation between the variables. Click Data, Data Analysis, Correlation, click OK, and make sure that data is selected from B1 to M39, and labels are in the first row, that's why we check here. And the output is here, and click OK. So you see the correlation coefficients table between the variables here. The correlation coefficient table shows that strong correlation between many of the variables. For example, the correlation coefficient between male and female mortality rates is 0.95, which indicates a strong positive correlation between the two variables. The correlation measure tells us that some of the information in male mortality of a country in the form of variance is duplicated in female mortality. However, if we remove one of the variables from the dataset, we may lose a sizable portion of the variance or information in the data. So if you apply PCA here, PCA can significantly reduce data dimension while retaining almost all of the information in the data. Next, I will show you how to use Analytic Solver to perform PCA on the health and population dataset. And finally, I will summarize our findings. Here, click on Data Mining, and then Transform, and then Principal Components. For data range, make sure that you select the data from A1 to A39 and click OK. First row contains headers should be selected, and then move all the variables under selected variables except the country name. And then click Next. Here in this dialog box, you see that Analytic Solver offers you two options for the number of principal components. The first option is to display a fixed number of principal components. The total number of principal components that can be calculated is the same number as the number of variables we have in the data. Therefore, the maximum number of principal components to display in this example is 12. The other option is smallest number of components, which display the smallest number of components that collectively explain at least a certain percentage of total variance in the data, where here the default threshold is 95% of the variance. Now we choose to display all 12 components. Analytic Solver also offers you the option of choosing one of the following methods for performing PCA. Use covariant matrix and use correlation matrix. If you recall from the previous videos, correlation coefficients are unit-free, and therefore choosing the Use Correlation Matrix option is equivalent to using standardized data for PCA. As I mentioned earlier in the previous video, it is recommended that data to be standardized or converted to z-scores prior to performing PCA when the scales are different. And when you check the health data, the scales of the dataset vary significantly. Therefore, we will choose Use Correlation Matrix option to remove the impact of data scale on the results. And then click Next. In the final dialog box, make sure the box next to Show Principal Component Score is checked. And then click Finish. Analytic Solver inserts two new worksheets. One is PCA output and the other one is PCA scores. You can see here on PCA scores worksheet all the principal component scores for the 38 countries. Here, record 1 refers to Argentina, record 2 refers to Austria, and so on. If you recall from the previous video that the principal component scores are the weighted linear combinations of the original values. Here on this worksheet, you can see the weights used to calculate the principal component scores and also the amount of variance accounted for by each principal component. We see that the first principal component accounts for a very large portion, 46.6189% of the total variance in the data. Among the original variables, life X has the most weight in absolute terms for the first principal component, followed by birth rate. Cumulatively, the first four principal components account for 93.3486% of the total variance in the data. This suggests that if we reduce the dimension of data from the original 12 variables to the four newly calculated principal components, we would still be able to retain almost all the information in the data. So this is how we calculate the principal components using Analytic Solver.